Hi, Assalamualaikum and hello everyone. We are from Group 3. Would like to present about the Mechanical Innovation Dominoes Challenge MIDC project. Before that, I would like to introduce my team members is Khairul, Hanif Balakrishnan, Pakis, Narmita, Sharul, Haris, James, and myself, Hazim. For our video contents, we'll have objective, planning phase, implementation phase, and reflection. Objective. In the process of completing this project, students will be able to apply and gain benefits from all the dynamics principles that are discussed in the class lecture, besides being able to work productively in the team and demonstrate basic leadership skills. Also, students can enhance the creativity and innovative in using kinetic laws. As example, solving problem and troubleshooting skills when design the structure and design specification of a station. Furthermore, this project presents an investigation on the motion of a falling row of dominoes with different dimensions. Motion is described in means of falling and collision. Dominoes are assumed not to slip on the surface. The equations are solved numerically, and comprehensive simulation program is developed by the means of angle specification of dominoes as the function of time. The program works for any given arrangement of dominoes with different height and distance. Video processing is used to measure the angle of dominoes in real experiments. Precise agreement between experimental results and simulation verifies the theory. In each collision, some percentage of the energy remains, some is transferred, and the other part is waste. This percentage are compared for different height, increase rates, and are used to design limitations.
Assalamualaikum. For this Dominoes challenge, we can relate with Newton's second law, or you can call it law of acceleration. The equation needed for this law is F equal to ma, or force equal to mass times acceleration. The SI unit of source is the Newton, while Newton of force is the amount of force needed to cause a 1 kg mass to accelerate at a rate of 1 meter per second square. F equal to ma basically means that the force of an object comes from its mass and its acceleration. The example is like glacier, something very massive which is very high mass that is changing speed very slowly. Low acceleration like a glacier can still have great force. Another example is bullet, which is something very small that is changing speed very quickly. Like bullet can still have a great force. Something very small changing speed very slowly will have a very big force. We can move to weight. Weight is a measure of the gravitational force that a massive object puts on another mass. The equation is force equal to mg, or weight equal to mass times acceleration. An object weight on a planet Earth in Newton is equal to its mass in kilograms times 9.81 meter per second square. Thank you.
Hi, Assalamualaikum. I will explain more about another topic that we gonna relate. It is chapter 6, work and energy of particles. So for the introductions, work and energy equations come from the work done equation, U equal to F times S, where U is the work done by a force F moving a particle or body with displacement. In this chapter, we must consider work done from displacement due to constant force. The subtopic is work done by a constant force, that is U equal to F times by displacement. And then we have work done by a constant force through cable. Constant force here means the tension in the cable is constant. And then we have work done by a constant friction force. Friction force direction is always against the direction of motion. Second thing that we must consider is energy due to gravity, that is height. Gravity potential energy comes from particle or object vertical displacement, height. If there is a change in height between initial and final position, then there is a change in gravitational potential energy. Next is energy due to elasticity or spring. Kinetic potential energy comes from spring element with stiffness. Symbol is K in Newton meter in a system. If there is a change in spring length between initial and final position, then there is a change in elastic potential energy. Lastly is kinetic potential energy, energy due to kinetic motion. Kinetic potential energy comes from motion. If there is a change in velocity between initial and final position, then there is a change in kinetic potential energy. All of the unit of work and energy is in Newton meter or joule. That's all. Thank you.
Hi, Assalamualaikum. for Group 3's Dominoes project, where we're required to relate our project to 3 main topics from dynamic. And for now, I will explain briefly about impulse and momentum. So for this topic, the equation used is mv1 plus f dt equal mv2, or initial momentum plus impulse equal final momentum. This equation is derived from Newton's second law equation, where force equal mass times acceleration, where impulse is the change of momentum. The basic principle of impulse and momentum is defined as the integral of a force acting on an object with respect to time. This means that impulse contains the product of force and time. Impulse changes the momentum of an object, and as a result, a large force applied for a short period of time can produce the same momentum change as a small force applied for a long period of time. In many real-life problems involving impulse and momentum, the impulse acting on a body consists of a large force acting for a very short period of time. For example, a hammer strike or a collision between two bodies. Thank you.